Hey, everybody, welcome to Commercial Construction Elevate the Industry podcast, hosted by yours truly, Dave Procida. The purpose of the podcast is to empower you to move along better through the commercial construction industry. And I'm going to do that two ways. We're going to introduce you to industry leaders, people who have influenced me and the industry at large, and you're going to meet one of them in a few minutes, as well as listening to me. I'm going to be able to share my personal experience with you. Been doing this for a long time now, and I think some of the things that I have to say will help you decide where you want to go in this business and hopefully help you get there sooner. So we're fortunate today to have someone who is, in my mind, one of the top building science professionals in North America and perhaps the world. Marcus Jablonka is Vice President of Operations and Marketing at Dorken, and all I can say is Guten Tag.
Guten Tag.
Listen, I want to thank you for joining us today, and I'm looking forward to this. Marcus, you're currently where?
Dave, before I start, I didn't know you were fluent in German as well.
I'm not. One word.
Very good. So thanks for the kind introduction. I'm in Beamsville, Ontario. That is just an hour outside of Toronto.
And we're going to get into your history, but for the listeners, who is Dorken?
Well, Dorken is a family-owned company headquartered in Germany. It has been around almost 130 years now. Originally started as a paint company, but it has evolved into other industries as well. And since the 60s, had a strong focus on construction protection materials. So at this point, the company makes drain boards for foundation protection, rain screen materials, air and water barriers, roof underlays, anything that keeps the weather, water and air out of the building. And a subsidiary was started here in the mid-90s in close to Toronto to service the North American market with products manufactured here.
So you're the Vice President of Operations and Marketing. Now, usually you have a Vice President of Operations and a Vice President of Marketing. You're doing both. How does that work?
Well, yeah, since the company is old in Europe, but relatively young in North America, as we started in 1995, and I joined in 1999, a few of us had to wear multiple hats, and that has continued through the years. We have had strong growth. We have obviously added many people to our team over the years, but I ended up with both those hats, as I had over the years developed strong relationships in the marketplace as well, especially with architects, with building science specialists, and kind of morphed into that. And I enjoy both responsibilities.
So we know where you are now. Let's talk about how you got there. You talk about your childhood real quick, and then we're going to get into how you got involved with Dorken.
Yeah, well, I grew up in middle Germany, in a little town called Herdecke. It's just outside of Dortmund, which is a soccer town and the beer capital of Germany. But beyond that, a rather quiet area. This is actually where Dorken is home as well. The corporate office of Dorken is home in that little town. My parents had a diverse background. My dad was born in East Prussia, my mom in Norway. So I have some little bit of Viking blood in my veins as well. And grew up in that area. My dad worked for the same company, for Dorken, for almost 40 years. And my plan had really not been to start working there. But so when an opportunity came up, I got asked if I would like to have an opportunity to work in Canada for some time. Actually, the original plan was for 1 year. I couldn't resist. I was hungry for adventure, and this is around 20 years ago now, going on 21.
Awesome. Now, you went to university. Tell me what you learned, or what are your degrees? You have several, so I'm not going to try and say what they are. You tell me.
Yeah, so I went to university in Germany. Obviously, before I moved here, I went for mechanical engineering with a focus on plastics technology. And after finishing that, decided together with a friend to add another program and went for a business degree at a different university. and then things took its course.
So, what was your first major job at Dorken?
Well, I started, so when the opportunity came up, this is summer '99, I got a phone call from a member of the supervisory board at the head office that I'd known since my childhood, and he was to me a mentor as well. And he said he was president of Dorken Systems in Canada at the time, leading it from Germany. And he said, I have an opportunity. Would you be interested in that? Our plant manager in Canada left. Would you take this on? And I said, well, I would. Let me check with my wife if she's willing to move as well, because she had to give up her career and job. But we discussed this and said, for 1 year, let's do this. And that's how I ended up in Beamsville, Ontario.
So you got a degree in engineering, heavy into plastics, and now you're a production manager
in a plastics extrusion company. So there was a pretty good match there. My plan at the time was actually not to become plant manager, but it was a good starting point for me as well, particularly in this company. I know now our process, our machines, how we make things, how we have improved things, and it has been a really enjoyable journey for me as well. Not planning at that time to stay here this long, but now I can look back at the past 20 years and have seen most of the development of this company, of this operation here in North America, and worked with a great team of colleagues and good friends that are all very proud of what has been built here from grassroots.
You know, the technical background that you have has to help you in the marketing side too.
Yeah, particularly when your company makes products that have technical applications and that oftentimes need technical explanations as well, or a technical understanding of what works in which application, why does it work, perhaps also to understand why doesn't it work or where are the limitations. I think it's helpful no matter what, in whatever industry we all work. It's good to know what a product can do, or when a product is truly recommendable for an application. It builds trust with the company, with the customers, with the market in the long term. It helps to build a reputation. It helps to build an image that stands for something, and that people start trusting in the long term as well.
You know, most people think of marketing as sales, and part of sales is marketing, but marketing is much more. It's understanding your place in the business, understanding the value your company has, and being able to promote that technically and personally, and you've done a really good job of that. So you're in Canada. You've been there for 20 years. You do a lot of business in the U.S.?
Yeah, meanwhile, so the first focus was obviously in Canada, and I can dive into a little detail on that as well. When we started operating here, the reason why we ended up in Ontario was really mainly triggered by a change in the building code. The drainage on residential foundation walls became mandatory, and a very effective solution and simple to implement or to execute was to use a drainage board like we manufacture. Because the need or the demand for such products grew rapidly at that time, that was one of the key reasons why Dorken very quickly understood the movement in the market and made the decision to build an operation here in Ontario. All of that together enables, on the marketing side, enables me, but not just me, the entire company, to offer technical products to real problems out in the market that Dorken has specialty experience in. And in many cases, we benefit here as a North American team from over 100 years of experience in Europe. Ultimately, many things, certainly physics, are not so different here versus Europe.
You know, as a contractor, I recognized, I think maybe 1996 or 97, that this air barrier. At the time, it was one product. It was a peel and stick impermeable membrane. And I'm thinking this could change things. And we engaged in that business, and man, has it changed. You're talking about the last 20 years, and it's been good because it's really, it's helped the building business, number one, because it's, improved the building science piece of it and how buildings are built and how they withstand different things. That's what you know. But for contractors, it's been great because the more technical things become, the more specialists are needed. And that's kind of where we stepped in. Now, that said, how did you morph from that business, mostly what you just explained, to the air barrier piece?
Yeah, so we always had access to the entire product portfolio of our parent company in Germany. I mentioned early on the company originated out of the paint industry, or the first products that Dorken made were paints. There is still a paint division in Dorken today, or now a coatings division, where also industrial type coatings are being made, anti-corrosion systems, quite complex. But then the other part, a large part of the company, is membranes, and in the membrane area there are dimple sheets or drain boards that truly are meant to provide drainage, for the most part below grade, but we also make products that drain above grade, behind cladding materials, so to provide an air and ventilation and drainage gap between cladding and the secondary water-resistant barrier. So with those products, we had a large portfolio, and one of the largest product groups in Europe that Dorken offers in Europe are actually roof underlays. You may know that the typical roof in Central Europe is built with open rafters and with clay tiles or concrete tiles or slate. If it's slate, then it's not open rafters. It's usually a boarded roof or a deck roof as well. But very typical, or pretty much the standard anywhere, is to utilize a roof underlay, because the clay tiles or concrete tiles are very good with wind loads. They're good with durability, with UV resistance, and so on. One thing they do allow is some water leakage from wind-driven rain under the tiles and then ending up on whatever is below. So if below is just open rafters, then some water, some small percentage of the rainwater will drip into the roof cavity, and therefore it is common or standard to use a roof underlay. This is what Dorken developed in the 60s as a synthetic roof underlay that would be vapor permeable. That was a market trend that Dorken quickly jumped on as well, and since then has become really a specialist in making vapor permeable roof underlays. Now, with those in Dorken's portfolio in Europe, we then had access to flat membranes, and that was really the beginning phase of introducing air barriers to the North American market with the technology that Dorken already owned and utilized at that time.
That said, the air barrier market now used to be air and vapor barrier. So now it's more just air barrier. And I think I know why, but I think you could probably explain it better.
Well, I'd say it's not just one or the other. There's still both, but not necessarily both in one. I think one really needs to distinguish between what is a vapor barrier, what is an air barrier, and when is which one required. I'll make an example, and I think we should when trying to understand that, always distinguish between commercial construction and residential construction. Let me start with residential construction, and thinking in cold climates now, like up here in Canada, in Ontario, or in the northern states. In residential construction, we typically build with wood studs, with wood sheathing, and we have typically cavity insulation. And I'm talking standard construction. Most people will have some mineral or glass fiber insulation in their wall cavity. In those climates, in the cold climates, you have to concern yourself about the potential for condensation in the wall cavity during the cold month, from interior moisture, and therefore we utilize a vapor barrier on the inside, on the warm side of the insulation. That means moisture in the air in the living space cannot penetrate through that vapor barrier and get into the wall cavity to condense there. So we're preventing moisture damage in the wall cavity by utilizing a vapor barrier. That's different from an air barrier. An air barrier you want to utilize to ensure you don't have air leakage through the wall. Now you can utilize a vapor barrier and perhaps still have air leakage into the wall, even though the vapor barrier itself is airtight, like say a 6mm poly. But if it's not taped at the overlaps or at the seams, or if it's penetrated by fasteners, it may still be a pretty effective vapor barrier, but it will not be an effective air barrier. And therefore, if air leaks through the wall, not only do we use energy through the wall, but we may also allow that air that leaks through to travel into the wall cavity and to drag with it moisture that can condense. So there's difference explained in residential construction. In commercial construction, we know we typically utilize steel studs. We use gypsum sheathing, and we then often see a vapor/air barrier installed or self-adhered to the exterior side of the sheathing material. Traditionally, self-adhering membranes have been bitumen-based or modified bitumen-based. In most cases, it's typically a polyethylene liner with a modified bitumen coating on it that then adheres to the gypsum sheathing. That being said, by nature, these products have always been vapor impermeable. The question is, are they meant as a vapor barrier, or are they meant to be utilized as an air barrier, or perhaps in some cases both? Now, in commercial construction, the insulation doesn't sit, at least shouldn't sit, and in most cases doesn't sit in the stud cavity, because putting fiberglass insulation between steel studs is not really the smartest thing to do, because you have a lot of thermal bridging through the steel studs. So in most cases it's done right, and the insulation ends up outboard of the sheathing and outboard of the air vapor barrier. And in that case, it's always good to have an air barrier in the wall to conserve energy. The question, is it really necessary to have a vapor barrier? That depends on the climate zone you're in and on the moisture loads. Do you have loads more from the exterior to the interior? Do you have loads more from the interior to the exterior? Is the wall cavity or the wall construction moisture sensitive or not? So there are a lot of factors that play into that. So we know that the building code in the US does not prescribe a vapor barrier everywhere in a residential wall, because it's not necessary everywhere. In fact, the building code has been changed and improved by taking the mandate for a vapor barrier out in certain climate zones, which was the result of the work of Dr. Joe Stiebrek, who for a long time pushed for that and said we're causing more damage than anything if you mandate a vapor barrier in the wrong areas.
You know, I thought I knew a lot as a contractor. I just learned a lot right there. But it's interesting because when I bid work, a lot of times I see things that just don't look right. But that's when I would call you guys. So we'll keep that there. Guten Tag. Anyway, you'll get that in a minute. I've been in the air barrier business for 20 plus years, from when it was a single asphaltic, peel and stick, impermeable membrane to what it is today. It's a big part of the building science. The business has changed. There are several manufacturers in it, but I choose today to deal with Dorken, a German-based company. Not only are they competitively priced, their technical support is great, and mainly, I can always count them. They're there when I need them, in the field or during the bid. The biggest single differentiator between Dorken and other manufacturers is they have a simple system. An example, on a previous job, we have 5 different products to do the same thing that Dorken gives me with 2 products. So Dorken, I thank you for that. My workers thank you. My clients thank you. I would urge you to check Dorken out at their website, dorken.com. That's dorken.com. Let's go back to your family. Like, tell us, you have a work life, you have a family life. You're obviously work. I assume you work from home now. Or are you working in the office?
Yeah, this is the office. I'm in the office. Yeah.
Okay. Tell us about your family.
So here, my immediate family is my wife, and I have 3 children, 1 daughter, 2 sons. They were all born here in Canada after we came. My wife and I married 2 years, I think, before we moved here. The rest of our family lives in Germany. My parents in the north. I have a sister in the north. My wife's family lives in the northeast. She has 1 brother and her parents and her 97-year-old grandmother. And
that's awesome.
We try to remain in touch as much as possible as a family, even with the distance in between. Obviously, there's an ocean in between, but we try with virtual media, obviously, and then wherever we can, we try to also meet in person. It's not that easy with that much distance in between, but we have been able over the 20 years to keep a very intact family relationship.
Very important. So your work life, family life is balanced. I noticed one thing on your LinkedIn profile, and we didn't talk about this before, but you are a conductor of an orchestra. How did that happen?
Well, I growing up, my parents gave both my sister and I the opportunity to also engage in music and to take music lessons. My sister has far more advanced than I was ever able to. But I grew up playing some piano and later on added bassoon. We had a very active school orchestra in our high school that would do some very exciting things. Every year we would travel into a foreign country. We did many trips to Brussels in Belgium, to London in the United Kingdom, to stay there for several days at a partner school, live in guest families, and then later on spend some days, typically 4 or 5 days in the city, like in downtown London, and go to many concerts, and anyway, get to know the city as you would in that age group. And out of that grew a continuous interest in music that has lived on for me until today, when I got to know my wife. She, more or less by coincidence, was a flautist and still loves the flute till today. So we got both involved in amateur orchestras while still living in Germany. And when we had moved here to Canada, we also tried to grow our roots and get to know people that had similar interests, and got involved in a church orchestra, a church that we attend. And in that orchestra, well, I did my duties in the bassoon section in the beginning, and later on was asked, hey, can you help us lead this group? So it's a group of typically around 45 amateur players. Young to 12 years to some have been in their mid-60s, and it has been a lot of fun. So we play at church events, sometimes in large venues as well. The highlight, I think, for all of us in that group has been to play in Roy Thompson Hall in downtown Toronto.
That is awesome, right? How do you get to that? But obviously it was a cool journey for you. Air Barrier Association of America. I'm very familiar with them because I think they, through their processes, have promoted, good, technically good sound, both specifications and installation. Now, are you on the board of ABAA?
I'm not on the board. I'm on several committees or member of committees. My colleague Peter Barrett, our product manager, is a board member of ABBA.
What do you think of the organization? Give him a shout out if you want to.
So I'm very fond of the organization. I have seen it get established and then grow over the years, right from the beginning. I know the executive director, Laverne Dalgleish, very well. He's a fellow Canadian, but spends most of his time, I think, south of the border. and he's one of the spearheads of this organization, the backbone, I would say, of this organization. Obviously, with a lot of the board members that are driving and they are putting a lot of energy into the organization as well. But Laverne has been an expert in this industry for decades. I actually got to know him through work in ESTM committees and saw him interact with the different interest groups and different stakeholders, and was always impressed with his work. And then when I saw him put energy into building ABA, that to me was always of high interest, to also see and observe the goals and try to do my contribution as well in helping the industry evolve and become better at building airtight buildings. Another driver in that was Vagdi Anis, who passed away a few years ago, but he was, I would say, the godfather of air barrier, and he was one of the founding members and drivers of the organization ABA as well. And we had a very strong relationship, and these things have perhaps biased me a bit more towards the work of ABA, but I do believe in the concepts. I do believe in the underlying ideas, in the things, in the programs they have been building, and what they're driving in the industry. And is now an organization that has built up a strong reputation and a strong pool of knowledge, a strong pool of experts involved with this organization. And therefore we have a vital interest as well to cooperate with them, and therefore my colleague Peter Barrett is also an active member on their board.
Yeah, that's big. Tell us about your knowledge and influence in Rainscreen.
Yeah, so Rainscreen, there I can perhaps start on right on that level. The newest or youngest organization in that area is RAINA, the Rainscreen Association in North America. It is just a little over a year old, and there I am on the board, actually on the executive board as well. And this organization is now collecting all kinds of knowledge and expertise from within the industry to funnel it and to help through the members of this organization to build the knowledge and the understanding for the need of Rainscreens and how to implement Rainscreens and how to make them work effectively in the entire construction industry. So that is pretty exciting. Now I can go back and also talk a bit about the other side. My first steps into the Rainfield arena I took around 2004. So a few years after I arrived here, and well, let me start here. I had some childhood memories of my mom, as I mentioned earlier, was born in Norway. So her family, half her family was basically in Norway, and every few years we would go up for family vacation to Norway, live on an island in an old family house that when I was a child, I was told had already been there for 120 years. It was wood construction. It was right at the ocean, so exposed to lots of wind and salt water and whatnot. But it was sitting there every time we came, and it was not falling apart, not rotting. There was no mold. And I only realized these facts later on after I moved here, and then started hearing a lot of people talk about mold issues in homes and moisture issues and pictures of rotten wood and how mushrooms would grow through stucco and all kinds of horror stories. And then as I was growing into or a bit closer to the building science community and got to know the experts in the industry and attended some conferences, I quickly learned that the specialists, scientists had long understood one thing that helps is drainage and ventilation. If you apply an absorptive cladding directly or almost directly, just with a piece of building paper in between over wood-based sheathing, then you're programming challenges or failures into the wall. And that's where it clicked with me when I remember my childhood. Why did this 120-year-old wood house, wood structure still stand there? Nobody would do permanent renovations on that. It would be there every year. We would come and still exposed to the elements. Well, it was because they had ventilation behind the wood cladding and allowed the moisture that would get in to come back out again. And so with this concept in mind, we started to manufacture, as I said earlier, in 1995, drainage boards for foundation walls here in our Beamsville plant. With the same production technology, we were also able to develop a product that could be used above grade. And it's basically a dimple sheet that provides an air gap behind the cladding. So if you now apply stucco or any other absorptive cladding like manufactured stone or even cement board siding, it is not directly applied to the surface of the water-resistant barrier anymore. In the simplest case, this might be building paper, but there would be literally no gap, or almost no gap, certainly not an effective gap to allow for ventilation if you direct apply. So by adding a dimple sheet in between, so now you have wood sheathing, water-resistant barrier, dimple sheet providing an air gap, and then the cladding. Now you're allowing for drainage and for ventilation. And in this particular case, because the dimple sheet is made of polyethylene and is vapor impermeable, it even stops solar-driven moisture. So any of the moisture getting absorbed during a rain shower in an exterior stucco layer or a layer of manufactured stone is now not able to get pushed through and into the wall. And so that was the beginning of me getting involved with rain screen, and that has become a journey for the Dorken company now over the last 16 years as well.
Well, if I were to try and answer the question I'm asked a lot, like Dave, describe what a pressure equalized wall is. There's a lot of different opinions on that. What is yours?
Yeah, so you will hear a lot of different answers and opinions on that, and some people will have very strong opinions. I like to side with people that I consider experts with the highest level of expertise. So I'll reference in this case Dr. John Straub, who was actually a student of Dr. Eric Burnett, and both of them have spent extensive time on researching pressure equalized systems. So let me say it in simple words before I really truly try to answer your question. In many cases, it's an overrated concept. I'm not saying that it doesn't work, but it's an overrated concept that one needs to be very careful on how to interpret, or how to apply it, or to what extent to say it is now a working pressure equalized system. The idea would really be that when we have a building, and it's perhaps easier to understand the concept when you think of a multi-story building exposed to rain and wind. On the side that is hit by wind and rain, you have a positive pressure. The wind is building up pressure and literally pushing the rainwater into the wall and through any openings or into any cavities it can find. Why? Because in that cavity or behind that wall layer is a lower pressure. So if you were to open the window in a windstorm, the rain would blow in. If you close the window, it has to stay outside, and obviously the wind or the air pressure on the interior side is lower. So if you now take that concept and say, what if we try to establish an intermediate layer where the pressure is already lower, or perhaps as low as the interior pressure, so that we don't have literally water sucked into the building anymore. And that is the concept that one would try to accomplish with a pressure equalized rain screen system. But again, how well that works depends very much on the configuration, on the size of the cavity compartments, and a lot on detailing as well. Here's what I would want to take away out of a long-winded answer like that. I think it's extremely important that somebody uses the right construction material in the right way and pays special attention to details, because most walls will not fail due to a wrong concept or due to a product, a membrane, whatever it may be in the field where everything is fine and straightforward. most walls will fail due to wrong details. So if you pay attention there, then we can solve almost any moisture problem.
So a couple of key words: continuous insulation. Now, your air barriers are impacted by dew points and everything and thermal issues. So what are your thoughts on today's concept of continuous insulation outboard of the sheathing?
It is a very good concept. It makes total sense. I'll make a simple analogy. If we go outside in the winter, it quickly becomes clear it's a good thing to wear a warm sweater or a parka or whatever, something that keeps us warm. And we also quickly realize if it has a zipper, on a really cold day, it's a good idea to close the zipper and to not let cold air come in through that. If we apply that concept to buildings as well, every building these days, certainly buildings that people want to live in, come with insulation. But we have learned over the years that it's helpful to put insulation into cavities. But if the cavities are interrupted by wood studs, not so bad, by steel studs, quite bad, we still lose a lot of energy because the steel obviously is very conductive, and that means we're making the insulation layer less effective and we're making the building less energy efficient. So why interrupt an insulation layer with steel, which obviously conducts heat very easily? Why not either use non-conductive materials for the structure, or why not move the insulation layer into an area where it can be continuous, like the zipped up sweater, so that you don't have any interruptions anymore in the insulation layer, and hence the word or the terminology continuous insulation makes total sense. When we have a need to insulate, we don't want to only partially insulate or discontinually insulate. We want to do it everywhere, and only if we do it everywhere without interruption, we have done a good job, which results in energy efficient building. So is it a good thing to do? Absolutely. Is it easy to do? Depends. There will certainly be challenges, but there are good methods to overcome those. Does it come with other challenges that are unrelated to the actual task of insulating the wall? Yes, they do.
So one of the products that has been emerging for over 10 years now is spray polyurethane foam. Now, spray polyurethane foam is almost like it's impervious to moisture, correct? So it kind of acts as an air and vapor barrier?
So there is open and closed cell foam. So we want to be careful on that. Generally, as a vapor retarder, I think most people will agree it will act as such to some degree. But there will be foams that let moisture through in form of vapor as well. So it depends again on the application. It depends on the particular type of foam and the thickness of the foam that is being applied on the building.
So NFPA 285, that makes it tough to use spray polyurethane foam outboard of sheathing, right?
NFPA 285 makes it tough for any flammable material to be used in wall cavities, and for good reasons.
So mineral fiber is the material of choice these days?
When someone wants to circumvent NFPA 285 challenges, mineral fiber insulation is certainly a very good contribution to not run into any bottlenecks.
I sense a but coming here. Is there a but to that story? What would you design in a wall if you were building a building for Dorken? How would you design the exterior wall?
Well, let me answer that this way. I think there are many good ways to build a wall, and one that needs to also decide what am I looking for in the wall. Not every wall needs to comply with NFPA 285. And residential buildings generally don't. Residential buildings burn generally very well, but yet we all live in them. So it doesn't mean that a building that can burn well is not something we want to live in. Depends on how quickly one can come out of a building. So if there were a fire to break out in our house, that's obviously not a good experience, but we generally have enough time to run out and get ourselves into a safe area. That is different in many commercial buildings. So if you're in a multi-story office tower or apartment building, say we all know the Grenfell Tower in England, where many people lost their lives. That's the problem when the fire breaks out in such a building and people in the upper stories do not have enough time anymore to get out before they're exposed to danger. And therefore, a standard like NFPA 285 makes good sense to force the designers and the material providers and those who install these products to think about, is this building safe? And how else do that but to run tests and to determine how long does it take under certain conditions for a fire to spread, and how fast does it spread, how far does it spread. So back to your question now, how would I build? I would say it depends. In my residential building, if I had unlimited funds right now and would build a new house, I wouldn't even think about being in compliance with NFPA 285 on that house. So I would use materials based on selection criteria like how well does it insulate? How well can a contractor deal with details and make sure that is continuity in the insulation layer? What is the cost? Well, if I have unlimited funding, I don't care. I don't care about cost, but in most cases, people would care about cost as well and say, what's the cost versus benefit of what I'm trying to achieve here? And if I can achieve a highly energy efficient building with particular solutions, then that is a good solution. Now, in commercial construction, you have to have the safety aspect in mind. We can't get around it anymore because it's building code and the standard has been established, and for good reason. And so in a commercial building, I'd say, there is a higher likelihood if somebody says, look, I have a wall assembly that has certain flammable materials in it already or on it, perhaps the cladding material, that gets me close to a level where I can't afford to put any more flammable material into the wall cavity, then it might be a very good solution to opt for mineral fiber insulation, to say like that is a non-flammable material, so it does not add any more fuel to the wall. It gives me very good insulation value. It is very resilient. And that in combination with the cladding I choose for perhaps optical or design reasons, still meets the NFPA 285 standard requirements, and therefore this is a very good wall.
Well, it's interesting that you say that, because life safety is what you're really talking about when you talk about things like NFPA 285 or a 2-hour rated system, right? An exterior system that's rated for 2 hours to give people time to egress if there is a fire. And we know, that's not always the case, but I've seen it in both businesses. I've seen it in the fire containment business, where back in the day, I won't even go to what year, we were installing insulation in high-rise buildings with no sealant on top. I mean, smoke. The safing was the wrong orientation. It wasn't compressed. We used glue pins on the exterior wall to hold up the CW90 at the time, the 8-pound mineral wool. It was 55 stories. I mean, this was happening all the time. So what happens is you get manufacturers who look ahead and say, this is where the market's going. Let's develop products to combat this. And I saw it firsthand with people like STI and Hilti and those guys. And today, the market is way different than it was 20 years ago. What's changed in your business similarly, if anything?
You mean with regards to air barriers in general?
Yeah, just how the building science has changed, how the codes have changed, and how, maybe you guys as manufacturers have had a part in that change through testing or whatever, developing new products.
Well, certainly, let me reflect for one moment back to what I mentioned earlier. When Dorken started here in Ontario, there had been a recent building code change. So that is what Dorken reacted to and said, like, we can help. There's a new demand in the industry. There's most homes that are being built with a basement end up with a wet basement. The insurance companies are questioning that and saying, what is going on and how can this be resolved? Because why would somebody build a new house and end up a year later with a wet basement? Isn't there a solution? And there is. well, if there's water coming into the basement, how about we drain it away? And that's where the building code got changed. There was a mandate for drainage around basement walls. It didn't have to be our solution. It had to be drainage, but our solution certainly was the most practical one and was very cost effective as well compared to, say, adding a foot of washed gravel on the outside, which would be very costly, very difficult to install, very time consuming, and so on. So there's one example of in this case our company reacting to an industry trend and turning that into a new opportunity. Overall, I'd say we, as much as many other companies, have obviously been working with the trend that started a good 12, 15 years ago, the trend towards green. In the beginning, there was more talk about green than there is today. I think the terminology has changed quite a bit, but it was a trend towards green. Later on, I think it was better specified. So today we talk more about the trend to more energy efficient buildings. Sometimes we hear about the trend to more sustainable construction. And I think in the end, it's a mix of all of that. There is the desire to use recycled materials in products in order to protect the environment. We also protect the environment and perhaps slow down or prevent some of the global warming effects by making construction or buildings in general more energy efficient. It was clearly determined that one of the largest contributor to greenhouse gas building was waste of energy, and it was also clearly established that a very large contributor to wasting energy is the construction industry, because the way we build buildings was not energy efficient. They weren't well insulated, they weren't very airtight, and there has been a strong trend to that, which is also reflected in the changes in building codes over the past 10 plus years. This is also where we saw the opportunity, in this case, with products that were already existing within our organization that needed to be modified and adjusted, partly redeveloped for North American requirements. But we basically started off by taking some of the flat membranes, air and water barriers typically used in roof cavities in Europe, introduced them to North America after some product modifications and adjustments to meet certain standards and building code requirements. But those are now part of our standard product portfolio for Canada and for the United States of America in the air barrier and water resistant barrier segment, both mechanically fastened and self-adhering.
Mark Twain once said, and I'm serious, it's the clothes that make the man. Naked people have little or no influence on society. The wardrobe was provided by Benchmark Clothiers, custom clothes to fit your lifestyle. You can find them on Facebook and Instagram at Benchmark Clothiers. And when you go there, tell them Dave sent you. So one of the things that you mentioned the word opportunity, and I'll put you on the spot a little bit. What do you think the next is there a next big thing coming from your industry, or maybe even just a trend? Where do you see it? Where do you see the industry moving next?
I think the trends that we have all been observing will continue. I think that we're going to see adjustments with regards to how effective things can be done. I think over the past number of years, not only has there been a strong trend, we got to make things more energy efficient, but the question has been more fine-tuned to how do we need to do that, and how do we overcome the obstacles that we have experienced now. We have all recognized it needs to be done, it should be done, it's a good thing to do, we're trying to, but we're also realizing it doesn't always work that well. Somebody pays a lot of money to have an extra airtight house built, and then does a blower door test and finds out it didn't end up being all that tight. What went on here? And we have worked with a number of builders that I consider now both experts and good friends that have learned that simply by doing and by trying, building a house, measuring, learning from what they have done, what went well, what didn't go so well, and then fine-tuning their methods. It's not just a matter of using the right materials. It's also a matter of using the right materials right and applying them with the proper details. So I think we will see an ongoing trend towards improvement of details, to expanding ranges of accessories, to make the life of the contractor easier, to allow them to do things quickly and effectively, and still in a manner that leads to a very impressive result. And then if we look at bigger trends in the industry, where are things going? I think one thing that has clearly moved into the focus for many people over the past few years is modular construction or pre-construction, prefabricated panel construction, where things can be to some degree factory controlled. So whatever can be built in the factory, you typically have more quality control than you have in the field. This comes with other challenges, which is once you bring these modules to the site, you still have to assemble them in a way that you take good care of those details and still achieve the results almost as well as you can in the factory.
You know, I think you're right, and I'm living it, because one of the things I'm doing now, and I'm using Dorken products, is we're building panels inside with exterior wall panels in a shop, shipping them to the site with the air barrier on it. Now, you wrap the rough opening, and part of what I love about your products is that, you know, we use 2 instead of 4 or 5, no caulking. It really is simple, but you have to pay attention to the details, because you can't do everything in the shop, and you've got to pay attention to how you tie the shop applied air barrier on the panel to these actual structure and to each other. And that's really where I think the rubber meets the road. But I do notice one thing, that Dorken is very big on training. I've seen some of the videos, and you talk about, you know, getting down to, you know, how do you do the sill? How do you tie the sill into the pier? And you know, these are the things I pay attention to. But talk a little bit about the culture of education at Dorken.
Yeah, so I think it is fair to say training has always been a very big thing for Dorken in the corporate culture, not only internal, but we also in the parent company Dorken in Europe. We have a very intense relationship with the roofing industry. I mentioned earlier that a core part of our business in Europe is roof underlays. So there has been a very strong relationship over many decades to the roofer industry. And we have quite a few master roofers on staff as well in our team. That's typically in the application support team, as well as in the development team, to understand the needs of the people in the field, to understand what they're struggling with, where they could use a new solution to make their life easier, to achieve good results, and to circumvent typical problems that occur. So that is part of training, and actually goes both ways. We try to learn from the people who actually do it in the field, but then we also go back once we have developed a product solution to go out and train them. We have tried to adopt this culture and this way to market here as well. We do invest a lot into training. We work together with experts as well in the industry. I'll make one example. A company like CI Life that does training sessions in live sessions, typically over several days. People get invited to Denver to do partially classroom and partially hands-on training to understand the concepts of why do certain things work well, and how can you achieve certain objectives with good product solutions. And then it goes into the back, and there is hands-on part with wall models and real products being installed by real people to understand how it's being done. So we involve ourselves with that. We do similar things with ABA. You mentioned the Air Barrier Association of America earlier on. They provide training that we regularly participate in as an active sponsor, and to show people how to install our membranes. We do a lot of in-field training, and then we offer training sessions also for the design community, for architects, in form of the typical AIA lunch and learns. Now during COVID times, not so much the in-person, but we have a lot of training modules online, and we have, due to the pandemic this year, switched a lot of our initiatives to webinar series, where we invited a host of building science experts that gave regular 1-hour webinars that were recorded, that we are also now providing in the online world. So there's a multitude of information available, and it's a good mix of more the building science principles, as well as on how these principles translate into real world solutions, and how you can solve problems with these concepts.
So differentiation is always a big thing with, the contracting community, and I'm sure it is with you too. And I think one of the things that differentiate you from the other manufacturers is you make all your own products. Tell us about that.
Yeah, so we do here in our plant. We make a range of dimple sheets, of foundation protection products, obviously from scratch. So we buy the resin, extrude, thermoform, and so on. But let me give another example for the roof underlays, for the self-adhering air and water barriers, vapor permeable products. All those are technologies that Dorken has, and to a good part also developed. It was not an off-the-shelf machine, but in many cases processes that were basically invented to come up with these product solutions. Let me go back to the beginnings of Dorken getting involved in roof underlays. This was at the time, the typical roof underlay would have been a polyethylene sheet. The first improved versions would have been reinforced polyethylene sheets, but these products were simply watertight and airtight, not vapor permeable. As the industry moved on and building codes became more stringent to require higher insulation values in the roof cavity, they were running out of airspace in the roof cavity, which led to a lack of ventilation, and therefore the potential of trapping moisture in the insulated cavity, and therefore the need to make the roof underlay vapor permeable. The first solution that Dorken came up with in the 60s was a micro-perforated sheet, so literally poking very small holes into the membrane, which would not allow water droplets to move through unless they would be under very high pressure. But these small holes would allow some water vapor to move to the outside, to diffuse to the outside. From there, technology moved on, and Dorken kept learning and developing new principles. And today we have a range of different types of products made with different technologies that are basically made, all individual layers made at Dorken in-house. So as an example, one of our standard products is a double layer spun bonded with a breathable film in the middle. We manufacture the spun bond, we manufacture the breathable film, we laminate those 3 layers together. We have another product that's based on a polyester spun bond material for high tear resistance, high strength. It is obviously very vapor permeable, and that gets coated with an acrylic coating. This makes this a very effective water barrier, very effective air barrier. At the same time, this product is highly vapor permeable, and it's very durable when exposed to UV light. So one subcategory of this product segment actually is a market leading product in the open joint or open facade part of the market, when architects want to design buildings that have open joint cladding materials that leave a 1/2 inch or 1 inch gap. For optical reasons, that means you have an interruption in the in the cladding material that would allow air and water to enter. So hence you need a air and water barrier right behind that. But because of the gap, you're also allowing UV light to enter, and most polymeric materials would suffer from that over time. This product has been specifically designed to withstand the UV exposure and to survive those harsh conditions.
You know, it's interesting. You are a true hybrid, a marketing guy with technical knowledge. I mean, it just flows off your tongue. It's awesome. Last question. If you were given by Dorken a 5-year period, reasonable funds, and they wanted you to start a business related to construction, I don't care what it would be, what would you do today? Knowing what you know, knowing where the future is going, if you were supposed to be a contractor, what would you do?
What types of buildings would I build?
No, what kind of contracting work would you do? Would you be a roofer, air barrier, cladding? What do you think? Because there are people listening to this who are wondering where they're going to go next.
It's a hard choice to make because I think there is so much potential in the different parts of the building for simple improvement. By doing things well with the right types of products and with the understanding on how to detail things. I'm not sure if I would have an easy time to decide, but I think the most interesting part I personally find is the above grade wall. It often gets complex. It is much dependent. Let me say it this way: if you build a basement here in Ontario, or whether you build it in further down in the south, you're always exposed to similar soil temperatures. Yes, in the winter it gets a bit colder here, but a few feet down in the ground, it's very, very similar, and you'll always have moisture in the ground. So basements are basements. Let me simplify it this way: above grade walls, there's a multitude of scenarios. There's the different climate zones. There are challenges like fire. We want to become more airtight in those areas. We want to become more energy efficient. We want to become more durable. I think there is a very vast amount of challenges that can be resolved, that actually the industry, the experts have the knowledge how to resolve them. It just comes down to doing it and helping everyone in the industry who is involved and who builds these walls to gain the experience that what works, what doesn't work, to work with the right materials, to work properly with these right materials, to understand the importance of details. And if I became a contractor tomorrow, I think I would love to tackle that and build good above grade walls.
You just described what I do every day. You know, I'm on the contractor side. I would love to have you as my technical guy. Seriously, I really appreciate your time spending with us today. I learned a lot about you. I learned a lot about building science, and there was a lot of great information there. So, Marcus, I can't thank you enough. I look forward to doing more business with you personally and with Dorken.
Thank you very much, Steve. It's a pleasure to speak with you.
And for all of you that are listening, thank you for joining us. Stay safe and stay tuned. Elevate, 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 elevate. All the music for the episodes, including our theme song Elevate, was provided by DMV producer Trey Skills. If you like what you heard, follow Trey Skills on Instagram at Trey Skills, TREYSKILLZ. That's TREYSKILLZ. So follow me on Instagram and Twitter at Elevate Industry. Check out my YouTube channel at Commercial Construction, Elevate the Industry. Visit my website, adicorp.com, ADICORP.com. Go to LinkedIn, search for David Procida, hit connect, and follow me. Please rate, review, and comment on this episode, and I look forward to seeing you next week.